All right, let's see. Let's bring the calculator up. And all right, and I also want to point out something. Okay, when I go into D2L.
Yeah.
Okay, here's 17. All right, so, okay, I wanted to point out this announcement that I put up. Retaking one test, and test 4 is a take-home test, okay? You're allowed to retake one test out of the first 3 tests. If you do the review for test retake in MyMathLab and score at least 80% on it for the test you're going to retake. You don't have to do all 3 of them. If you want to do all 3, you can. It's not worth points, but anyway. You should also practice the worksheets that we did for the test and check against the posted solutions. Remember that problems should be worked algebraically unless stated otherwise. So make sure you understand. And when I ask for exact answers, it's not a decimal to 4 places. And in this last test, a lot of exact answers were between 0 and 2 pi. So it was supposed to be in radians. Okay. Test retake day will be Tuesday, April 25th. And we will review for the final exam on Thursday, April 27th. The final exam is Tuesday, May 2nd from 9 to 11 a.m. So I'm going to hand out the take-home test a week from today. And you have to turn it in on Tuesday. I'll post something about that too. Okay. Just want to make sure you guys know, be clear, and I'll be making the take-home test this weekend. All right. But I want to make sure you know that you get to retake a test, but it's not free. Okay. I don't want you to do poorly on it, so I'm asking you to do this extra math lab. But if you just do the extra math lab and use your calculator, you know, you're not really preparing for the test. So that's why I said, look, go over the notes, but you're supposed to be doing things algebraically. So, anyway, that's, so, and I will pass around a sheet asking you which test you want to retake another day, okay? So, now, I want you to turn in the take-home test on Tuesday, the 25th. So if you're not retaking your test, you can just come and turn that in and leave. But I recommend you retake a test. I do replace your lowest test grade with the final, so I'm doing both. Okay, so to help you out, I'm doing both. So you can really improve your grade at the end here. But don't, if you have 2 low test grades, don't count on the finals. The finals comprehensive is going to be harder than a retake. A retake is easier than the final. So go ahead and take advantage of this opportunity if you have a low test grade. All right. Any questions? Okay. All right. And I will go ahead and I'll post something about that later. I'll make sure I give you clear. Okay. So we were on section 6.3, but before we talk about that, let's talk about the worksheet that you were supposed to do, participation grade. If we've got two sides and an angle, side-side angle, triangle given, determine whether the given measurements produce one triangle, two triangles, or no triangle at all. So you don't really have to, you have to use h, the height is b. And basically, if A is greater than H, and A is less than B, and I wrote it down here, you have two triangles. So in this problem, you had two triangles, but I figured this out. You have to make sure you label your stuff right. Little side A is across from big angle A. Little side B is across from big angle B. It doesn't matter if you switch these around, but you have to have these across. And this is the law of sines, and in order to use it, you have to use the law of sines. So these problems are the law of sines, and I cross-multiplied and solved for sine of B. And then I got that B1 was 62 degrees. I made sure my calculator was in degree mode because I wanted degrees. So then I drew the coordinates here. If we have a B2, reference angles, remember, are against the x-axis. So if we got 62 for B1, we'll have to have 62 here. So B2 is 180 minus 62. And then the C2 is 180 minus A plus taking A, the 50, so the other thing is sometimes people in problems are putting like A over sine of B. No, we're going to keep A, small side A has to be over sine of A. Small side B has to be over sine of B. Small side C has to be over sine of C. You don't switch it up like that. It's going to be wrong. Okay. All right. So I'll post these after class. Any questions on this one? Does that clear up anything for you? This next one actually had two triangles also. It was in the notes from the law of sines, which I posted this page here. This is the law of sines, the second page. If you don't have to figure out by taking, you don't have to do B times sine A. You find H. If this is a no triangle case, if you set up your law of sines and solve, this would get sine equals an impossible value of sine. Sine has to be between -1 and 1 inclusive. So we got an impossible value, so this was no triangle. And here was a two triangle. over 180. So 149 degrees plus 43 degrees. B times sine A. But you can, if you like that method, you can. Okay, and I posted that under this homework. All right, well, let's go on and talk about 6.3 again. Everybody come in after it took roll? I don't think so. Oh no, I saw you. And let's see. I think I have some of these papers. From pole P. So plot the following polar coordinates. So I'm just going to show you, I was doing that last time. We've got positive 3, 315, 3. So 315 was here, positive 1, 2, 3. So this is the point, 3, 315, polar coordinates. Negative 2 pi. Let's make that bigger. Okay. So minus 1 minus pi over 2. So minus pi over 2 would be this and 1. We start at the pole and we go in the opposite direction. And we're up here at minus 1 minus pi over 2. And then the last one was, it's in orange here. You can't see these things. Okay, I drew it at 4. It doesn't really matter. You could draw it wherever you want, but start at the pole, and you're going to go toward the pi over 4, 5 units, and that's 5 pi over 4. We did those kind of in a hurry last time, but that's how you do that. So you're going to figure out your angle, and then you have to start at the pole, and if it's positive you go toward the angle, if it's negative you go against it. Okay. Presented as, so r theta can be r comma theta plus 2n pi. Or r theta can be negative r theta plus pi plus 2n pi, where n is any integer. Five pi over 4. In which r is positive and theta is between 2 pi and 4 pi. So we've got 5 pi. R positive is going to stay 5. Then we're going to take, we want to get between 2 pi and 4 pi. So we're going to add 2 pi. And that's 4. Nine pi over 4. Do a picture here. If you like to see it visually. So this is pi over 4. We'll make 1, 2, 3, 4, 5 marks. So this point is 5 pi over 4. Let me get some other colors in. Okay, got more color. So, right. So 9 pi over 4 would be this. You know, so it'd be this point, but you go, 9 pi over 4. Right, 9 pi over 4. All right, we're going to find a point where another representation where r is negative, so that means we have to have negative 5. So it's probably easier to figure it out with the picture. So we gotta go over here. This is our angle. We're gonna go to this angle and then go at negative 5 is 1, 2, 3, 4, 5. So what's this angle? And they're asking for it in radians. I have to be specific on the test. Okay. All right. So this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. I just counted in pi's over 4. Okay? Does that make sense to you? Okay. All right, the next one, r is positive. So if r is positive, it's going to be positive 5. It's not going to change to 2 or anything. And now we want a negative angle. We want theta to be between negative 2 pi and 0. So we're going to go like that. What's that negative angle? 1 pi over 4, 2 pi, 3 pi over 4, 4 over 4. Negative. Okay, so you can do it graphically, but you could use these formulas up there. Any questions? Okay, so what's the relationship between polar and rectangular coordinates? The coordinates are x, comma, y. So here's the relationship. So here's some examples. We're converting points from rectangular to polar. Okay? This is r theta, or mark it as r theta up here, however you want to do it. So x equals r cosine theta. R is 3. Theta is pi, so we write and put cosine of pi. Okay, where's my circle? Here's one. Cosine is the x coordinate. That's so right here. -1. So it's 3 times -1 is -3 equals r sine theta is 3 sine pi. Sine of pi was 0. Equals 3 times 0 equals 0. The xy coordinates are -3, 0. Look at the graph. Imagine, you're going to sketch a picture. This is the pole. We're going to go pi, and then we're going to go pi. We're going to go 3 toward pi. This is the point. Pi is polar. Okay, the next one. So again, right. So x equals r cosine theta is -10 cosine pi over 6. Pi over 6 is here, cosine is square root of 3 over 2. So, and that equals -5 square root of 3 over 2. And if I ask for a decimal, that's 0.66. Y is r sine theta -10 sine pi over 6 the y coordinate here is 1/2. So it's so the rectangular points x, y are minus 5. You gotta write x first. Minus 8. .66 approximately, and minus 5.
When do you get rid of the 2 that's under -5 squared?
Right. Thank you. And I think my number's still right because I'm yeah. So it's minus 5 times square root. Right. Thank you. So if I asked for an exact value, you would have okay, so that's converting from rectangular coordinates, and it's a point. Just converting a point. To convert from rectangular to polar, we're going to plot the point x, y. Find r using the square root of x squared plus y squared. And then find theta using tangent theta. This is converting a point from rectangular to polar coordinates. Okay. Now, we're going to, let's see, let's write it. Okay. Convert an infinite number of polar coordinates. So we're going to choose the representation for polar coordinates, where we're going to choose where r and theta is the smallest positive number, a positive angle. Passing through x and we'll do that. So you can check with calculator polar to rectangular x comma y. That's how you, from rectangular, and we'll do that. R, we find R in one command and theta, the angle, in the other. But that'll give you the approximate decimals. And notice in the section we're pretty much using Okay. So we're going to find the polar coordinates. This is number 9, an example. Coordinates are 1, negative square root of 3. We're looking for a point, the polar coordinates. And we're going to pick the ones that are positive, a positive r, and the smallest positive angle between 0 and 2 pi, and I'll write that down. So we graph this. I'm just going to do it right here. What is the square root of 3? It's okay. I almost had it. Square root of 3. Yeah, 1.73. Good. Okay, so so 1, 2, this is negative 2, negative 1. So what? And if this is 1. Square root of 3. Okay, so this is our triangle. This side's 1, this side is negative square root of 3. And I don't know. Maybe you could see. I have it. I think my picture at home is a little better, but so we expect to get so we're going to find R with the, and we're going to find theta. We'll find the reference angle first. Okay. So you're going to find R with R equals the square root of 1 squared plus minus square root of 3 squared is the square root of 1 plus 3 is the square root of 4. 2. All right, and then tangent tangent, let's call this theta prime. Tangent, the prime is going to be tangent inverse of square root of 3 or negative, but you're going to have to adjust it to make it a positive. Second, tangent inverse of negative second square root of 3. Oh, guess what? We want to be in radians mode. Okay, and we could also use our unit circle. Figure that out. Tangent is sine over cosine. Cosine theta prime. So and you know, we know it's minus 60 degrees, but if you want to put sine over cosine, let's get the calculator out of the way. I'm going to use your unit circle. Minus square root of 3 over 2 divided by 1/2. Right here. And that is minus square root of 3 over, and you get minus square root of 3. Okay, and by the way, when you're multiplying fractions, you never flip the fraction, you don't flip the second one. Or I could have canceled right here, but that's easier. But that's when you're dividing. So it is minus pi over 3. This is minus pi over 3. So, and we can do that on the calculator. Our calculator gave us a decimal. We can do pi by 3. And I didn't put the negative sign, but so this is pi over 3. Okay. So now you've got, that's your point. But, no, it's not. It's not. It's negative. We've got it. We want the positive representation. We want the positive angle where theta is between 0 and 2 pi. So we can look at our unit circle again. If we're down here, the positive angle is 5. So it's 5 pi over 3. So if you could use your unit circle and come up with that first without coming up with this reference angle, that's fine. It's 5 pi over 3. Give us a number between minus pi over 2 and pi over 2. The inverse function, because of the restricted domain of tangent, but we wanted the positive value here. So you have to be able to convert those angles. Draw the picture and figure it out. Okay, question? So, the correct answer, 5 pi over 3. This is our r theta. To convert equations from rectangular to polar. Now we're converting equations. Before this, it was point. So that's an important distinction. From rectangular to polar. To convert a rectangular equation x and y to a polar equation theta and y with r sine theta. Convert the following rectangular equation to a polar equation that expresses r in terms of theta. So we're replacing x with r cosine theta, r cosine theta minus r sine theta equals 6. Now they want us to find r in terms of theta, so we want to get r on the left by itself. Three cosine theta minus sine theta equals 6, and then we divide theta. 3 cosine theta minus sine theta. It's 6 over all of that. And so r, this cancels. So I'll write it again. R theta minus sine theta. All right, the next one, x squared and y plus 1 squared equals 1, that's the equation of the circle. We're going to replace x with r cosine theta. And we're going to replace y . And then we have to remember our rules of exponents. If you square a product, you square each individual factor. So this equals. And now we're going to need to FOIL this. Now, so I'll do that. R sine theta plus 1 times r sine theta plus 1. It's first. So it's r sine theta times r sine theta. So that's r times r is r squared. And sine theta to sine theta is sine squared theta. That's our first term. FOIL. I'm figuring you need to see this. So outer term is 1 times r sine theta. The inner term is the same thing. And the last term is 1 times 1 is plus 1. So combine your like terms, this is understood one. These are your like terms. So you have r squared sine squared theta plus 2r sine theta plus 1. And that is what goes some algebra here. That's what goes here. Plus r squared sine theta plus 2r sine theta all right, then we can factor r squared out of these two terms. Oh, this is sine squared. I forgot that. Sine squared. Okay, we're going to factor an r squared out. Cosine squared theta plus sine squared. Okay, that equals 1. Okay, so I'll write the rest of this. Equals 1. This is the equation. I forgot to write the equals 1 here. So we got that. So we have this equals 1, r squared times 1 is r squared. So we have r squared plus 2r sine theta plus 1 equals 1. And when we subtract the 1 for both sides to set it to 0 to see if we need to factor, you need to set to 0 to factor. So we always set. So we have r squared plus 2r sine theta equals 0. Factor the r out. R plus 2 sine theta equals . Then we set each factor to 0. I'm going to go up here. So either r equals 0, but that's the pole, a single point. Or r plus 2 sine theta equals 0. So r equals . And if this is going to include the pole, so this is our answer. Minus 2 sine theta. Okay. All right, and the last couple things. To convert equations from polar to rectangular, we use one or more of the following equations. Squared plus y squared, or r cosine theta equals x, or r sine theta equals y or ty. To use these equations, it's sometimes necessary to decide the tangent of both sides or use an identity. Now you see why we're covering this after we've covered the other stuff. Okay. Or multiplying by r. There's lots of good examples in the book, and we're going to cover what we can here in 7 minutes. All right. So we convert the polar equation to a rectangular equation. R equals 4. So we're going to square both sides. And then r squared equals x squared plus y squared. We have x squared plus y squared equals 16. Okay, the next example, we take the tangent of both sides. Three pi over 4. Tangent of 3 pi over 4 sine over cosine. Sine over cosine is -1. So tangent theta, but tangent theta is y over x. All then, for y, you multiply through by x. So y equals -x. All right, the next one, it's secant. We got to rewrite secant. Secant theta over cosine theta. Now I multiply through by cosine theta. So I have r cosine theta equals -2, -2. Okay, we have an r equals 10 sine theta. And we know that r times sine theta equals y, so if we multiply both sides, So we subtract the 10y. Oh, we're gonna complete the square, sorry. We're gonna complete the square. X squared minus 10y plus 25. Oh, I went ahead, no. Okay. We write x squared plus y squared 10y plus blank. We've already subtracted the 10y, this is set to 0. Then we take half of minus and square it to complete the square is negative 5 squared, 25. So you can put the negative 5 squared here, or you can write 25, but if you add 25 to this side, you gotta add 25 to this side. This is completing the square. And so it's x squared plus y minus 5 squared equals 25. This is the equation of a circle. There's a vocabulary check. Okay, see you on Tuesday. I'll post some film